Hello and welcome to an asynchronous lesson. Today we're going to do a couple things. The first is that in your email you should have access to a water quality project folder where you are going to be uploading a new file from your drive to upload your water scarcity project. If you have a project that isn't necessarily a Google slide, it might be a good idea to just upload a Google Doc with your URL to that presentation. Your title for each of these should include your name so people know whose project is who when they're uploading it. Now, the main part of today is going to be finishing your water quality solutions and also taking some notes on some initial ideas related to the carbon cycle. So I will just say this about your water quality projects. When it comes to the end of your presentation or your project, when it comes to finalizing solutions, it's really important that you put the first three sections of your project in terms of the where, the why, and the possible solutions together. You really want to think about how you can solve your problems and the reasons for their existence with the specific solutions that you talked about earlier. So within my two projects here that I'm proposing for solutions, I talk about the problem, I talk about the reasons why it's happening, and I also talk about how my solution in terms of its abilities, its components, its costs, its pros will allow it to adequately address that problem, either in a specific location or a specific location with a specific problem such as high population and water scarcity, or water stress and irrigation for crops. That's going to be really important for thinking about how you convince people to spend money on your project. Now, we talked today about the components of making a puffy coat puffier and warmer, and we talked about different types of insulation, more insulation, and also the material that is used to capture the heat or absorb sunlight. So with these three slides, I just want you to use the handout that I gave you and write down some notes in the box next to each of these images, so you have a better idea going into next week what we really care about when it comes to the greenhouse gas effect and the carbon emissions. Now, energy is formed in stars, especially our sun, which is the nearest one due to nuclear fusion. We talked about that at the beginning of the year. And as that radiation, that energy that's invisible, travels through Earth's atmosphere, it contains a lot of energy. And some of it is going to be initially reflected back out into space by clouds and other things are in our atmosphere. But a lot of it, a majority of it, is going to be able to hit Earth's surface, about 168 watts. So roughly 1/2 of all of the sun's initial energy hitting Earth's atmosphere is going to be absorbed by the surface. Some of it's going to be maybe reflected off by ice caps or other high albedo surfaces, but a lot of it's going to be absorbed by the surface of the Earth. And as the surfaces of the Earth warm up, some of that heat will leave back into the air, sort of like a hot plate on your stove. And as it does it, it's going to interact with greenhouse gases. And greenhouse gases are invisible gases in the atmosphere that can easily absorb and capture energy from heat and radiation. Now, as those greenhouse gases absorb the heat, their energy levels go up, they expand, and they cause the air to actually warm due to all of those increased movements and collisions. Think of a game of pool where the initial stick hitting the balls is the radiation from the sun, then the scattering and movement of all of those balls is the energy being transferred to the greenhouse gases. The greenhouse gas effect causes us to retain about 100 grams of solar radiation from the initial 343. So we're capturing about 1/3 of all of Earth's energy when it comes to the sun giving us all of that energy. So about 1/3 of all solar radiation is going to be captured by the Earth's greenhouse gases. Now, we talked about this. How do you make a puffy coat warmer? You add more insulation, or you change the type of insulation. So for hundreds of thousands of years, this process has been reasonably stable with some up and down transition periods, such as ice ages, but for the most part, the greenhouse gases have been pretty consistent in our um, atmosphere. The problem is that based on historical values, different types of insulators, different types of greenhouse gases are really on the rise due to human activity. A jacket without any insulation would not keep you warm. You would die if you went out in the winter without a coat that didn't have any insulation. But too much insulation can also be dangerous because it causes too much heat to be trapped in your jacket. It's why you didn't show up today dressed in the clothes that you normally would wear in the winter. Now, not only has the amount of greenhouse gases gone up quite a bit in the past couple hundred years, but furthermore, we're introducing new types of gases into the atmosphere that normally wouldn't be there. So nitrous oxide and fluorinated gases, and even methane, tend to be 25 to 10,000 times more potent, 25 to 10,000 times better at capturing heat than carbon dioxide. And a lot of these are not natural, meaning that they are more or less produced by human-specific activities, especially nitrous oxide and fluorinated gases coming from human industry, such as air conditioners and refrigeration. And that leads us to the last component, which we were starting to deal with today. The surface of the Earth is the other major factor in terms of energy and heat being retained on our planet. Remember, Earth's surface absorbs about 1/2 of all of the energy coming from the sun, much of which will either be trapped as heat on the surface or reflected back into the greenhouse gases. So when we change the surface of the Earth, we're really changing how much heat can be trapped on a particular continent or landmass, and how much heat is then going to be released back into the air. As the temperatures of Earth's surfaces become higher and higher, it means that more and more energy is going to be passed out into the atmosphere, making the greenhouse gas effect even stronger because there will be more heat for more greenhouse gases to absorb. So the question that we're going to be dealing with next week in our labs is what happens when you change Earth's surfaces, such as deforestation or the melting of ice caps or the desertification of arid lands, but also change the CO2 concentrations. I hope that this has been a little bit of a review from maybe prior science classes, but also putting some pieces together. Note that again, water vapor is a powerful greenhouse gas, so there's a really good connection to the water unit that we just talked about. And also, in terms of soil health and soil cycles, degradation and the decline of fresh water are two really important factors, not only in the water and soil cycle, but also in the carbon cycle. Have a great rest of your day, and I'll see you soon.